Hello guys, again welcome back to our channel, and this time we will be introducing a term in trigonometry, and we have coterminal angles. So aside from defining this, so we also have to give on how a sample problem on how to come up with the coterminal angles of a given angle. Okay, now first we have to define what a coterminal angles are. So coterminal angles are angles in standard position with the same location of terminal side. Okay, so two angles like alpha and beta are coterminal angles if the alpha is equal to beta plus n times 360 degrees. So use this when the angles is expressed in degree. And you can use the second equation if the angle is expressed in terms of radian. So, the terms are the same. Alpha is equal to beta plus n, but you replace the 360 degrees with 2 pi. Actually, these are values in complete rotation for both in degree and in radian. Now, what's alpha? Alpha is the given angle, while the beta is the smallest positive, or it can be the smallest negative, which is the fractional part of a complete rotation. So it is the smallest positive angle if the given angle is also positive. But it is the smallest negative angle if the angle alpha is also a negative angle. While n, that represents the number of complete revolution. But before, actually this is a formula, but before using this formula, let us solve the problem by first using the geometry of figure only. Now, we are given an angle of negative 570 degrees, and then we are asked to give the smallest positive and negative angles that's coterminal to the given. Okay, since the angle is not so large, no? Now we can plot it. So, negative angle are angles that is produced by clockwise rotation, and being an angle in standard position, our initial side will actually start on the positive x-axis. Now, you notice here that we have values like 0 and n. 0 is for 0 rotation. N represents any complete rotation like 1, 2, 3, or any value representing a complete rotation. Now, if the rotation will be like this, if we have to take a clockwise rotation, so this is a quarter of a rotation, so 0.25 revolution right here. And then when that is again rotated, so this is 0.5 or a negative 0.5, this one. Then we also have a negative 0.75 up to this part, then one complete rotation. Correct? Now, if that is 570 degrees, so you can add another 90. We did not express our angle in terms of revolution because this is just very small. Now, so instead, we can have it as by adding 90 degrees, so we have 450. Another 90 is added, so there is 540 degrees, a negative 540 degrees right at the negative x-axis. Correct? Now, if that's 570 or negative 570 and this is only 540, meaning I need to add more 30 degrees further. Now, so to make it equal to negative 570 degrees. Now, at the positive x-axis, this represents a complete rotation. And if this is considered na to have the given angle, then meaning this is only a fractional part of a complete rotation. Correct? Kana. Now, this fractional part of a complete rotation, that represents your angle that is coterminal to the given, and this is the smallest negative angle. But if you consider the same terminal side and take a counterclockwise direction from the positive x-axis to the same terminal side, then this is the smallest positive angle. Now, the value of this angle can be taken, can be identified by having 90, another 90, correct? Then 30, so that is negative 210 degrees. That can be seen from the figure. Or if not, we can have this also taken from the figure. We know that the angle is negative, so I just put my negative before the bracket. And I know that this is 570 all in all, correct? So, I remove the complete rotation value, which is this one. That is 360. So when that is subtracted, so there is a difference of 210 degrees kanang nahabilin. And since the angle is negative, so there you have a negative 210 degrees that represents the smallest negative angle. How about the smallest positive angle? So, we can consider the smallest negative angle, and if we are after for the smallest positive, just add the smallest negative angle with 360 degrees. So, minus 210 plus 360 degrees, that gives you 150 degrees. So, if you are confused with the formula, you can always go back to your figure. If this is 30 degrees, correct? Then, this is 180, so that means this is 150 degrees as answer. So, that can be taken from the geometry of the figure. Now, second, we are increasing the value of the angle. Okay, now if you are going to plot it with multiple rotation, so it will take time. Instead, I'll be reducing this in terms of number of revolution. The number of complete revolution, so I have to convert the 6,330 degrees to revolution. So I can divide it by 360 degrees and I come up with a value of 17.58333 revolution. So there is a complete revolution of 17, and we also have a value which is in decimal, which will help us determine the location of our terminal side. Okay? So, the fractional part of the rotation, by the way, this is also equivalent to the smallest positive angle because that angle is a positive angle, which is in decimal of a revolution, or if you remove your 17 directly from your calculator and press equals, then that will give you a fractional form of 7/12 revolution. Now, you may convert this directly to degree. Pwede na ka mo arrive with the smallest positive angle. Okay, but for purposes of analyzing our figure, so I have to show the graph. Okay, so now where is the location of the terminal side? Now, take note. The angle is produced by counterclockwise rotation, so 0 rotation. This is quarter of a rotation, so expressed in terms of decimal, this is 0.25 revolution. But the value in decimal is 0.583. Okay, so that's beyond. So this is 0.5 if we continue. And that's even more than 0.5. So that is why the value can be obtained in between the 0.5 and 0.75. But I think it is closer to 0.5. So we can approximate the location of our terminal side, which is this one. Okay? Now, looking back on the figure, this is my smallest positive angle, which is the decimal value of the complete revolution, which is this one. In fractional form, so we also have 7/12 of a complete revolution is the smallest positive angle. Okay, so that can be reduced back to degree and we can have the required angle. Okay, the smallest negative is when we take the opposite rotation, correct? Okay, so what would be our answer? The smallest positive angle is the fractional part of the complete revolution, correct? Which is, again, be converted to the units as the angle is given. So, 7/12 revolution, or you may have the value in decimal, but do not round up a value. The value coming from the calculator will be used directly to avoid rounding up of digits, even if you use a decimal. Now, multiply that with 360 degrees according to conversion factor. So, we come up with 210 degrees as answer. So, for the smallest negative, again, we can have the smallest positive subtracted by 360 degrees, and the result is negative 150 degrees. Now, when the term was introduced in our first slide, so there is a formula that is being stated in the definition, correct? So, we have to recall that one. The formula runs as this. Alpha is equal to beta plus n times 360 degrees if the angle is in degree. This is in degree. So, I'll be using this one, correct? Now, the angle given is 6,330 degrees. And this fractional part of a complete rotation must also be positive. So, your beta is the smallest positive angle. Our n is the integer value. That is 17. we multiply that with 360 degrees. So its result will be subtracted to 6,000 or to the given angle. Then we have a difference of 210 degrees. This is our answer. The smallest negative is equal to the smallest positive, 210 degrees minus 360 degrees. So that is equal to negative 150 degrees as answer. So if you notice, we can go directly with the answer using this. So what we need is only to convert that in terms of revolution and make use of this formula. So this one may not be needed anymore. Okay? So the next problem, we will be using this formula in arriving with the positive, smallest positive, and smallest negative angle, that's coterminal, to the given. And here is the given in number 3. The given in number 3 is an angle which is formed by clockwise rotation. That is expressed in terms of region, correct? So, what is the number of revolution there? Okay, so the given angle, we have. So, that's in region. This is my conversion factor to revolution. So, 1 revolution is 2 pi region. So, perform the operation, we have a negative 4.928 revolution, approximately. This is the value of n, the number of complete revolution. So, I can consider the formula this time. So, alpha is equal to beta plus n times, we will be using 2 pi because this is in region. Take the given angle here. So, this fractional part of a complete rotation is the smallest negative angle because the angle here is negative. What is our n? That's negative 4, correct? Then, we can multiply that with 2 pi. When that is combined, so we have minus 69 over 7 pi plus 8 pi. So, this is the result for the smallest negative angle. Now, for the positive angle, the smallest negative will be added with 1 complete rotation. And 1 complete rotation here is 2 pi. So, 2 pi is added, and that is minus 13 over 7 pi, added with 2 pi. So, the smallest positive is equal to negative, and is equal to 1 over 7 pi as answer. So, you will notice that the problem can now be solved easily. Okay, let's try with an angle in degree by directly using the definition ganina. N is the number of complete revolutions. Given angle is 55,504 degrees. In terms of revolution, that is 154.177 revolution approximately. Our N is 154. And what's the formula to be used? Alpha is equal to beta plus n multiplied with 360 degrees. Okay, substitute the value. That's the given. 55,504 degrees. The angle which is to be determined is the smallest positive because the angle is positive. Okay? Complete rotation of 154 is multiplied with 360 degrees. So there we have a difference by combining them, and that is 64 degrees. Okay? Then, next, the smallest negative is equal to the smallest positive, which is 64 subtracted by 360 degrees, and we arrive with the result of negative 296 degrees as answer. So, I think, our little problem in determining the coterminal angles of the given angle is medyo ni sayon na ugamay, no? So, that's all I can share to you with topic on coterminal angles. So again, thank you for always being around here. And for those who are new in our channel, so I hope you won't forget to subscribe and maybe share this to others. Okay, so thank you and good day everyone. Hangtod sunod na tong lesson nga atong ma-share diri. So, hope to see you again. Bye-bye.